So now the time has come where I am going to help you all to deduce the chemical formulas of the following compounds. The first one in consideration is going to be sodium sulfate. But before that, let me give you a recap of something that helps us out over here, giving the chemical formula for a particular substance, called as the crisscross method or the cross multiplication method. Think about this carefully. I will have my metal always to the left and it will have a valency of 1. In a similar manner, I will have my non-metal to the right and let its valency be represented as valency 2. Now, because it is the crisscross method, because it is the cross multiplication method, what is going to happen? The valencies are going to get exchanged. In that particular number, the number which was there with the non-metal is now valid for the metal and it comes into the downward direction. And a similar manner, the number which was valid for the metal now goes to the non-metal and it comes into the downward direction. So, we will have the metal, the number next to it is going to be the valency 2, which is the valency of the non-metal. Similarly, we will have the non-metal, bracket we will have the valency of 1, which is the valency of the metal. Let's begin, let's have a look. Okay, who do we have first? We have sodium sulfate. Now, step 1, to write down the symbols of the radicals, always basic to the left and acidic to the right. Let's begin. So, we have NaSO4. How did I get that? I have sodium, which is Na with a charge of 1 plus, and I have sulfate, which is SO4 with a charge of 2 minus. So, I write down Na to the left and SO4 to the right. Great. Who do we have next? To write down the valency below the respective radical. So, Na 1 plus, SO4 2 minus. So, I have Na, below that I will write down 1, SO4 below that I am going to write down 2. Great, no problem still here at all. Now, times for crisscross. Now, to cross multiply as shown, we are going to make down arrows with respect to the number of radicals. So, I have NaSO4, the 1 is going to go to sulfate and the 2 is going to go to sodium. Great. What is going to happen because of that? The 1 when it goes to sulfate, it's a number that you write or don't write, doesn't make any difference. But the 2 that goes to sodium, that has to be written. So, what is the chemical formula which is now going to come? To write down the chemical formula of the final compound, I am going to get Na2SO4. Now, that solves my first part. Let's continue. So, sodium sulfate, there we have it. Ferric phosphate is next. Step 1, to write down the symbols of the radicals, basic to the left, acidic to the right. Ferric is Fe, right? Phosphate is PO4. So, let's write it down. We have Fe and PO4. Now, what do we need to write down? We need to write down the charges associated, the valency associated. Ferric, higher valency. Fe with a charge of 2 plus is ferrous, Fe with a charge of 3 plus is ferric. So, Fe with a charge of 3 plus and phosphate is PO4 with a charge of 3 minus. Let's write it down. So, there I have it, Fe with a charge of 3 plus, phosphate, that is PO4 with a charge of 3 minus. Great. Now comes the time to crisscross. Before that, one must understand that both of these numbers, that is 3 and 3, they are perfectly divisible by each other. They are going to perfectly cancel each other. So, I must reduce them. When I do that, the new valencies are going to become 1 and 1. 1 is the only number that if you write or you don't write, doesn't make any difference. Now, since it doesn't make any difference, what is going to happen over here is, let me write down FePO4 the way it is, and then let me exchange the radicals. The one of Fe goes to PO4, the one of PO4 comes to Fe, and when that happens, I get my final formula for the compound ferric phosphate, which is nothing but FePO4. Wonderful. Now, if you've understood that, the next one is pretty similar. Let's have a look. Okay. Calcium carbonate. First, let's write down the formulas. For calcium, it is obviously going to be Ca. For carbonate, it is obviously going to become CO3. Basic to the left, acidic to the right. Once that is done, what do we need to do? Yes, we need to write down the valencies, the charges associated. To write down the valency below the respective radicals, Ca with a charge of 2 plus, CO3 with a charge of 2 minus. Do you see something similar happening over here? Yes, 2 and 2, perfectly divisible. Divide them by a common factor, get them to the lowest number possible. When you cut 2 and 2, you're obviously going to get 1 and 1, and that's the radical that you need to exchange. But remember, 1 is the only number that you write or don't write, doesn't make any difference. So, now for calcium carbonate, what are we going to do? Let's have a look. We are going to have Ca to the left, CO3 to the right, 1 to the left, 1 to the right, exchange. Now, 1 is the only number, as I said, write or don't write, doesn't make any difference. The final formula is obviously going to become CaCO3, and who's that, my dear child? Perfect, it happens to be calcium carbonate. Fourth and final one, to finish off this particular concept, who do we have? Sodium dichromate. Slightly difficult, think about this carefully and answer. So, let's write down the formulas first. Who's sodium? Na. Whose dichromate? Cr2O7, right? Now in this particular case, basic to the left, acidic to the right. So we have Na to the left, Cr2O7 to the right. Then write down the charges. Then write down the valencies associated with them. Sodium is Na with a charge of 1 plus. Cr2O7 with a charge of 2 minus is dichromate. Do you see any reduction over here? No, it's already in the most reduced formula anyways possible. So now comes the time to crisscross, to cross multiply. Na with a charge of 1 plus, Cr2O7 with a charge of 2 minus. The 2 of Cr2O7 goes to Na, the 1 of Na goes to Cr2O7. 2 is a number that you will have to write. 1 is a number that you write or don't write, doesn't make any difference. So let's not write it down. The final formula for sodium dichromate is going to become Na2Cr2O7, and that, my dear child, is sodium dichromate.